So in this video, we want to look at what we call completing the square. So I want to write, let's say, x squared plus 6x plus 8 in this form. I want to write it in this form. So I'll write this quadratic in this form that we call by completing the square. And so many students are actually having difficulties actually do this, and it can be looked at in many ways, many ways. And so I'll be looking at this in probably two ways to show you how we can actually look at it. I will actually go in depth for you to understand the concept, just not to memorize anything, but just to understand the concept of how it goes. So what we want to look at first is, what do we mean by a square? Complete square, completing the square, a complete square. So if we should go back to square numbers, so that we say that raised to that, that raised to that. We said it is actually 2 times 2, which is the same thing as 4. This is the same thing as 3 times 3. That's 9. So if we actually look at these numbers are actually completed square numbers. And if I were to actually represent this concept in an algebraic form, if I were to actually, let's say I want to represent, I should actually write this in this form. Well, what we could do, we could actually work this out and to actually, try to match them equivalently to see what works with what matches with what, and so we can actually have a better understanding. Let's work out this part first, this part. And so if I should actually work out x plus a raised to the second power, will actually multiply by itself. So we have x plus a times x plus a plus b, and so could actually distribute. This is a different color. Could actually distribute this times that times that. So we have x squared plus xa plus xa plus a square plus b. Oops, let me see, I can write it some more better, a little better. So we have x times x gives us x squared plus x times a gives us xa plus a times x gives us xa, just the same. And we have a times a gives us a squared, and we write back our b. And we could actually simplify this expression. We could say, write back our x to x squared. These two will give us 2xa plus a square plus b. Now, this part of the expression is a completed square part. That's a completed square. And so, if we should actually write this in the form of that, then we'd have to write this in a completed square. And so we actually would represent this quadratic by completing the square. And that's what we always want to do. So this is actually a completed square form. Well, this part and this constant is added to it. And so let's just look at it. Let's spend some time to look at it and see what is what. Now, what we could actually do, let's look at something here. Now, this quadratic expression is basically, we can actually write this quadratic expression. We can actually write this quadratic expression. Well, not write it, but match the x's. Well, alright, so this quadratic expression, we could say, okay, this x squared is the same thing as this x squared. This 6x is the same thing as this 2xa. And so, but we don't really have we don't have a number for this yet. We can see that, well, this constant probably there is actually this, but let us look at it further in further detail. So this x squared could not, this a squared, we don't have a squared for it, but we can actually find, we could say, let us write this a different way there. Let's say we have x squared plus 6x. I'm going to write that constant out there, because what we want, since we've got this here, give us a complete square, which is coming from this. And so if I'm to write this in this form, then I have to separate this constant. Like this constant is actually separated. And so let's look at it. If this is x squared, and this is x6, 6x, and which matches this. Question is, what would a be in light of that? What number number a would be? So when it is multiplied by 2x, we get 6x. Well, a must be 3. So if a is 3, then we can substitute a for here as well, which will give us 9. And this here would be a complete square. This can be written in a complete square. This is a complete square, and so the constant 8 will be outside. But whenever we have an expression like this, whenever we add something to the expression, we can't just add it like that. So for us not to affect the expression, we'll have to write, if we add a 9, we subtract a 9 as well. So we put that 9 where the constant is. So if I were to actually write back this expression, I can actually use that 9 to cancel the other 9, and we have the same original expression from the beginning. So if you add a number, you put it back. But whenever you always add a number to put it where the x is, the number that you add, the number that you get for a, you always put 1 and group it where the x's are, and put 1 outside with the other constant. You always do that. And so let's look at it. Let's continue to look at it. And so this could be written, if this is the same thing as this right here. And remember that this is actually coming from this. So if we can actually write this like in that. We could actually do it that way. But all we want is just the x. What was the a? The a was what? 3. And it is what? All square. What is the constant? The constant would be -1. And that's it. That's simple it. So this is just bringing you to the cons, showing you, like proving the form. That's kind of building the concept from the foundation. And so we could actually work this out, and it actually give us back it will actually give us back the original expression. You could try it if you want. You could actually try it. You could say x times x give us x squared. I would say x times 3x give us 3x, because actually multiplying it by itself. And we say what now? We say now x 3 times 3x give us 3x, and we say x times x, no, 3 times 3 gives us 9 minus 1. And so if we should simplify, we have x squared plus 6x, and 1 from 9 gives us 8. And so we get back the same thing. And so that's basically like completing the square, going this way, going back to the original part, and so on. So we could actually look at this in just a clearer way. So let's erase this thing now. So if I were asked to write this in a complete square, well, in this form. Now we could do this many ways. We could actually do the same concept, the whole idea thing. We could remember that this actually gives us x squared plus 2 2xa plus a squared plus b. That's what all of this gives us. All of that gives us that. And so if we were to use this quadratic expression to match this, we could actually say, okay, we could actually do this. We could say this x squared is that x squared. This represents this. So what would be a in this case? Because if we have a, we can just simply just write this quickly and get it over with. What is a? A is what? What is a? A, 2x times a number gives us 2x. What would that number be as relates to a? That must be 1. And so that is one we could actually write it as 2x plus 2. I've been keep on saying 2x, but it's actually x squared. So we have x squared plus 2x, and so a would actually be 1. And so if that's the case, we just say, all right, 1 raised to the power of 2 gives us 1, and what we had, so this will actually give us a completed square. This will actually give us a completed, the square that we're getting, completing the square. This part gives us the completed squared idea. And so we actually have, we add 5 from the beginning, and so we're going to subtract 1, because if we add 1, we subtract 1. And so we could actually write this down in this form, very simple. And so what was a? A was 1. So we could say x plus 1 raised to 2, and we work this out. That gives us 4. And so we would have written it in that way. Let us do another one, and then we look at the other way we could actually do it. Let's say we have, so we're looking at this example, x squared plus 10x minus 1. I should write it in that form. And so we could actually just write down this in the expansion form as a completed square. And so we actually have, let's say we have, we have x squared plus 2xa plus a squared plus b. I will actually just match these. And so what would we actually have? X squared, what would be, in this case, we have 10x plus 10x. Now what would a be? Because we need to have the squared number to be added to the expression. What would a be? If I should say 2x times a number gives me 10x, what would that a be? A would be 5 in this case. So if I should square 5, I get 25. So if I actually, this actually give us a completed square. This will give us a completed square. And so we could actually write this as that. But before we do that, let us write back our constants. And if we add 25, we subtract 25. And so we could actually rewrite this in this form. What was a? A was 5. The constant will be just negative 26. And that's it. Now, if you should understand something, this value will always be half of anything that is there. A will always be half of whatever is there. And so we're going to look at another way we could actually look at it. Let us erase this thing. So if you should actually work this out, you'll actually get the same thing. You get back this originally. You get back this if you were to actually work this out. And so this is actually writing a quadratic expression in the form of this by completing the square. Now, if you were asked to, let's say, and so if we were actually given a quadratic just like this, and instead we must write 2x squared plus 32x plus 18 in that form, a outside with a bracket x plus h raised to the power of 2 plus a constant outside. And we'll do the same. Basically, it's very simple. Now, in this one, what we're going to do, just imagine we have a quadratic like this. Oops. And we have a quadratic like this. So now, if you look at it, this will actually be representing that, this will be representing that, and this will be representing that. All right? And so if you were to actually write this quadratic in that form, what we have to do, we would have to factor, we would always want to have the x square having no coefficient per se, or no, let's say we'll always factor the coefficient of the x square. So we're going to factor all the terms by the coefficient of the x square. So we'll take out the 2, and what we have is x squared plus 16x, and we'll bring the constant outside, which actually be a 9. Okay? And what we have in the bracket, we want to actually get a we want to actually write what is in the bracket as a completed square, and we know how to do that. And it's the same concept if we had this kind of thing. Remember this one, the x squared plus 2x that plus a squared plus beta, but we actually say this represent that represent this, and to get this, what we would have to do, and it's just the logics of it, to get that squared number, what we'll have to do, we have to now divide this b by 2 and square it. Divide it by 2 and square it. Divide it by 2 and square it. And so we'll actually write, and that would be our number, the squared number that we're going to add into this bracket, and also subtract it with the constant outside. And so we have 2x squared plus 16x. Half of 16 is 8. When we square 8, we get 64. Plus 64, close bracket, plus 9 minus 64. And so because the thing is, remember this. Whatever number that we add in the bracket is always going to be squared. It is always going to be squared. Always going to be squared. And so remember that anytime we actually should write this in this form, we always would actually, the a in this case, this will actually be, this one right here actually be half of whatever this is. And so if that is always half of whatever it is, if it should go right here, we'd have to square it. If you should remember the steps, we will actually square it. After getting, so the half of that is always squared. It is always squared. It is always squared. Whatever number that goes here, it is always squared. And that same number here, the square root of it, is what is inside of the bracket, with the x plus the constant outside in the form of that. And so let's look at it now. So what is in the bracket is a complete square. It is a complete square. So how would we actually write this? We would write this as this. We write this as this. We have our constant outside, x inside. We write half of this, which would be actually the square root of that. And so we'll actually be having 8 all square. And when we work this out, we will end up with negative 55.